Good afternoon, everyone, and welcome to this edition of NexusForum Talks. This time focused on the cloud edge for AI. This is our NexusForum Working Group public webinar where we will be discussing emerging hardware, software stacks for next generation AI workloads across data centers, edge platforms, and embedded devices where latency, energy, reliability, and data locality are first-class constraints. Just to give you briefly what we'll be discussing today. So we'll be having the project overview, and after the project overview, we will be moving on with our fireside chat, or let's say the NexusForum talk. And then we will be having time for the Q&A. So I encourage everyone that has joined, if you have any questions, please do write them in the chat, and then we will be able to address them together with our speakers today towards the end of these sessions. For the ones that have not had the opportunity yet to get familiar with the NexusForum project, the aim of the project is to boost the consolidation of the European computing continuum, which means that we provide a forward-looking and bold vision in new areas and directions. We do that with our several key objectives, which is to deliver a strategic outlook on the cognitive computing continuum future. We do that as well through production of annual research and innovation roadmaps, as well as a policy and research recommendations. We also tackle and nurture the European computing constituency. We incorporate various types of stakeholders, and of course, we engage research and industry ecosystems and relevant initiatives in strategic democratic countries of the EU, and also with a special focus on Japan and South Korea. We also have these 10 thematic working groups within the project. So 4 of them are research oriented, 4 of them are industry oriented, and we also have 2 that are geographically oriented. Now, without the further ado, I would like to give some space for today's speakers to present themselves, why this also topic matters to them, and how they contribute to it. Today we'll be joined with Björn Forsberg and Philippe Bonnet. Björn is part of the Research Institutes of Sweden, and Philippe is part of the Department of Computer Science of the University of Copenhagen. So without further ado, Björn, please, the floor is all yours.
Thank you. Yes. Hi, everyone. I'm also from a Department of Computer Science. So just to give some grounding here to the topics that we are going to discuss. I'm the academic co-lead for the working group Cloud Edge for AI in NexusForum. So that has been my role to coordinate a bit the talks and around the topics, and sort of shepherd them into the roadmap that Daniel was referring to in the goals of the NexusForum project. I'm also a researcher at the Research Institutes of Sweden. That's what I'm doing day to day. I'm especially focused around low-level software stacks, especially on compilers, and with a special focus towards memory orchestration and these topics that are very relevant today. Yes.
Thank you very much, Björn, for the introduction. Philippe, the floor is all yours now.
Thanks. Thanks for inviting me first, Björn. So it's a pleasure to be here, and I'm a big fan of the roadmap. I think you've done a very impressive amount of very high quality work. So I think it's a very important thing for the commission, for everybody, and so I'm happy to be here. I'm a professor at DICU, so the Computer Science Department of the University of Copenhagen. My background is in database systems, but I've been moving closer to storage the last many years. What we're so in terms of research, what I'm looking at is the co-design of the hardware and software with special focus on data movement. I'm coordinating a EU project called Chorus, which has been running for a year. It will be running for 3 more years. We are developing, the focus is on near data processing in the cloud. and we're focusing on developing open and programmable accelerators for near data processing. So we're looking at the observation. The key insight is that smart NICs and solid state drives are already full of processing elements, so they are computational devices. And we should leverage that. When I say we, it's not just the cloud providers, but also the data systems designers. They should be able to program the flow of data and manipulate data as it's flowing through inference or, for example, inference accelerators.
Thank you very much, Philippe, also for the introduction. We have prepared a set of questions for our speakers that we find relevant, not just for the roadmap that's being prepared and finalized, but also relevant questions to the ecosystem. But we also encourage everyone that is present now, if you have any questions, please do write them in the chat and we will address them later. So moving on to the first question, I would like to start first with Björn. So Björn, in your opinion and your experience, what is currently the biggest bottleneck for the next generation cloud edge AI systems? Is it compute, memory, communication, or software portability, or something else?
Yes. To start to answer this question, I'm thinking it's good to first understand that the next generation cloud edge AI systems, this includes a lot of heterogeneity, right? In at least two dimensions. So we are thinking both from the scale IoT and edge up to, big data centers, HPC, and so on. But we are also thinking about, what levels of acceleration do we get in these systems at the hardware level? Like, do we have, ISA extensions for specific functions? Do we have accelerators? How do they work? How are they interconnected? So in some sense, all of these are relevant, right? Because with this heterogeneity, we need the software portability. And since we are working with AI systems, we are doing a lot of computation. And the more we accelerate that computation, the more the memory becomes the bottleneck. And that's sort of the big topic right now. I would say that's not controversial to say. And then for the compute, of course, where and how do we do computation? So all of these are super relevant. But I think if I had to pick one, it's the sort of, what is memory and what is computation here? That's also, a long discussion, but it's somewhere there, right? That's where the bottlenecks are. So that's, I think, where most of the focus has to be. And this comes both from the hardware perspective, we have to build the hardware that supports this, and of course, all the software stacks, programming models that expose this. But we also need to have all the compilers and all of these things to manage this. So one last point before I pass on to see if Philippe agrees with me here, or if I'm saying something controversial. So from the perspective of, we can optimize the systems for many different things. Do we want the shortest response times? Do we need as many flops as possible, or do we need energy efficiency, or what are we optimizing for? And also in this aspect, there are different things to consider with respect to how we build our systems and how we program our systems. I think at least what I'm seeing is more and more software managed memory. And this also becomes, one of these co-design cross-cutting aspects, because traditional programming languages, of course, compute was expensive, so that's what you expose, but you need the abstractions to talk about memory. And you need a compiler to do all of the coordination if you have software managed memory, so you don't bog down the application programmer with device semantics. And of course, you want this to be portable. So yeah, it all ties together. A long answer that says everything.
This is actually what we wanted. Thank you very much, Björn. Philip, from your point of view, do you agree with Björn? Is it computing? Is it memory? Is it something controversial? So what is your...
No, so I think I agree with everything that Björn said. But I think looking at the question, I'd like to. I think there are a few. We take a few things for granted in the discussion, which I believe are worth spending some time, at least, making our assumptions explicit, and that's where maybe some of the controversies actually are. So the first question is who cares? So who cares? So who gets to define what cloud edge actually is? So it's been around for cloud edge. This notion of continuum has been around for some times. I used to believe it was a EU terminology. I found out, to my surprise, that OCP, so the Open Compute Project, has adopted the same kind of terminology. So they're talking about the AI continuum. So I was at the OCP European Summit a month or so ago. I was really shocked by the fact that in the context of OCP, you basically have the hyperscalers, so the big non-European guys, who are pushing for scale. So scale is the only thing that matters, and AI systems are. It's also so in terms of cloud edge, they only care about very large scale. So megawatt racks. That's how they measure. If a rack is below a megawatt, it's no longer in a range of what they're interested in. So there will be so cloud is so cloud in the hyperscaler sense is moving radically towards very high scale, and what it means is that the rest is edge or is part of. And there's a terminology issue: is how do you define what is not whatever hyperscale, hyperscaler scale. So if it's basically anything sub megawatt rack is no longer part of what they focus on, and they've been driving the entire industry for many years. So there's a lot of people who've invested a lot of money. I mean, Denmark has built some relatively large data centers a year or so ago. They're no longer in the ballpark. So they're, so there's I think a lot of interest for a lot of people in Europe, I believe in Japan as well, to look at what is not data center, very, very large data center scale. And some data centers are going to be in that space. And it goes all the way to IoT or to whatever telco has been considering edge as well. So there's a terminology issue and the scale of heterogeneity. The question is that the same? It's just so you were talking about this dimension of heterogeneity. Is it just one space, and is there only one scale, or are there subspaces which are very distinct? And so we are going to design software will be designed for one part of the space or another part of the space. I think it's an open question. And I believe another point which is important to make is what kind of AI systems are we looking at? Again, the hyperscalers are essentially looking at LLMs and so tokens and then and agentic AI is driving everything. So I believe at OCP every talk started with agentic and I think in the roadmap it's also has a very dominant, a very clear position. I think so. There's an open question on so it's not my domain. So I'm just reading. So I think many people will have very strong opinions on how what's the evolution of AI systems and so neurosymbolic. So where are we going to evolve? And I think it's important to, in terms of co-design, to have a good understanding of what kind of systems are we designing for. So that would be my take. So I fully agree with everything that Björn said.
Perfect. Thank you very much, Philippe, also for the questions that you imposed that are open. Really, really interesting. Now, since you also have the mic open, I would like to target the second question first to you. So, what do you think? Will memory-centric and near-memory architectures become essential for efficient edge AI workloads? So, what is your take on this?
So I think so. If you so again, if we consider so edge AI workloads again, so we would have to define exactly what it means. But in a abstract way, I guess it depends on two aspects. The first one is whether um, you're considering neuromorphic computing as a way to achieve efficient AI systems. And if that's the case, then the obvious answer is yes. I mean, with neuromorphic computing, then you have to mix computation and memories. So that's one part of the answer. The other part of the answer is what's the so what's the business model? What's the business case? And who's driving those systems, and if modularity and reuse of existing components developed in other contexts is an issue, then we might still be stuck with a layered system. So the question is are there incentives enough to move away from the traditional CPU centric? And the question is whether Moore's law is enough, or whether and so we're working towards having, demonstrating the viability and the interest of those architectures. I believe the fact that LPDDR6 is part of the JEDEC standard comprises processing in memory is going to make some of the fringe research a bit more mainline, and so we'll see how it impacts those workloads. But obviously, AI workloads are a very good case for processing memory or processing, so any form of data processing.
Thank you very much, Philippe. Björn, so what is your take on the question, but also on the insights that Philippe has shared now with us?
Yeah, I broadly agree. I think, I mean, memory-centric will definitely be, if we just take that word in isolation, that will be definitely relevant. The way I look at it, I spent some time in embedded systems, and there we like to talk about resource-constrained devices. But the truth is, of course, depending on what we mean with AI, I will circle back a little bit to that. For many workloads in this, what we see in this AI world are actually every system is resource constrained, right? And the main constrained resource is memory. So definitely, I mean, I think no question on the memory-centric part, and that is true not only for the edge, but it will be, more clearly the problem there, right? The less resources you have, the more precious they are. I think also on the question here on near memory architectures, I'm not an expert in this area, but the way I think about it is that right now there is a lot of work going on. We are seeing a lot of development in modular architectures and computer architectures everywhere at the same time, but at very different rates, right? And this one of the slower of these ones is, of course, putting the architecture into silicon, right? And then there are technologies beneath that, and they move even slower and so on. So there's a stack here that moves at different speeds. And at that point, it might be hard to make a business case to make near memory architectures. On the other hand, as soon as things stabilize, I think this will be the very clear win in terms of energy efficiency and so on. So essential, I can't promise, but this is the direction I see it going. Then, as one last thing, circling back here on the question from the previous point about is everything but this biggest scale, is that edge, right? Here, there is definitely also very important to define this, right? Because if we are thinking about, for example, robots or anything like that that are executing AI workloads, then we are definitely having to take into account this in a very different way than if we are, in a big data center and we are doing some sort of liquid cooling or whatever. And there, even the problem takes on a different shape, but near or in-memory architecture will be much more relevant, much more quickly earlier. And this can perhaps also be one of the questions on, what is the thing we should focus on a bit, right? Because, yeah. But I'll stop there. Yes.
Can I add a couple of things?
Absolutely. Oh, it's
Good. So I just wanted to so I think a lot of the advances in traditional data centers came from economies of scales from other industries. So ARM processors coming from mobile. So there might be a case. So I think a lot of work on memory-centric processing has been done for mobile devices, and there might be so there's a world where it takes off in that space and it's being repurposed for edge AI workloads. So that's one point, and the other point is I think for me one very interesting question is who's going to drive this? Who's going to drive this evolution? And historically, it's been so big. So back in my days, so Intel was deciding everything that everybody was running after Intel, and then so now everybody's running after NVIDIA and the big hyperscalers. The question in that space, whatever edge AI workload is, the question is who's going to drive and maybe it's going to be the automotive industry, and then it's then European companies might have a primary role to play, and so that's one point. And the other point is so one of the things I'm thinking a lot about is how to transfer. So how so what's the role of research and researchers and universities in Europe in the context of such an evolution? And historically, people have had an impact. So I'm thinking about P4 in the networking space, or RISC-V. Obviously, those things come from academia. So there might be, and the question is, what kind of model is needed for academic research, European academic research, to have an impact in that space? And I think it's a very open question, so I don't have a good answer, but I think it's so that's one of the things which I believe, and I believe OCP, RISC-V, or forums that would be, make some impact possible.
Thank you, Philippe, also on this, and Björn for sharing your 2 cents. Absolutely, if someone as well here that is part of the webinar, one of our participants, if you have an opinion on who is going to drive this, which sector, please do let us know in the chat. What is your opinion? And then we can discuss it later on. Now moving on to the third question of the day. I think we can now start again with Philippe. So Philippe, your opinion. So can today's compiler and runtime stacks really support heterogeneous AI hardware at scale, or do we need new abstractions? So what is your, let's say, controversial and uncontroversial take on this?
So any day we need new abstractions, so regardless. So that's that's what I do. So it's one thing, but people have had. So the thing is that there's a large space between. So to take another example, database systems and compilers. There's this gap, and that very good people have done a lot of very interesting work in bridging the gap between high level, high abstraction systems and compilers which are very flexible, but which directly target so intermediate representations down to the ISA. So there's a lot of space in those intermediate representations. And what kind of abstractions do you need there? I think is is a very relevant question. So that's something we're working on in the context of, so assuming SSDs are programmable, what are the abstractions and how, what are the, so what are the abstraction and what are the appropriate intermediate representations and what kind of high level language, if you're going to define a new NVMe command set every day, what kind of compiler, what kind of language compiler and most importantly, internet presentations are going to, with abstraction, are going to support that. So yes, I think it's a very important question.
Thank you, Philippe. Björn, your insights on the question?
Yeah, I agree that the abstractions are key here, and I mean there are two aspects the way I see it, or well, I think the quick answer to this question is sort of, but no, right? Can today's compilers and runtime stacks really support? So one of the things, so zooming in a little bit on the AI, which is driving a lot of development in this area as well, it's a entire stack thing. There is a there has been a big shift in the early days. There were, a lot of different stacks that developed few backends, compiler backends targeting usually CUDA or NVIDIA, and then some, maintained CPU part. And then there were many AI frameworks, and they each developed their own. And then, we had this huge problem. And what we have seen now over the past, 10 years, and especially perhaps in the last 5, is sort of a convergence, not fully, but quite strong towards MLIR, to have, this toolkit to build these intermediate representations that Philippe was talking about, and have different front ends for the different frameworks and shared backends for the different architectures. And this sort of architecture that exists today, right? So from that perspective, the compiler technology that exists today, I think is well positioned to handle this. But the implementations and the abstractions still have a long way to go. And of course, here we are talking about what are the big questions are really what are the abstractions that allow us to manage this data movement, for example, in very different architectures, computing in memory to software managed memory, more of a Neumann style, to, big data centers with, memory shared over multiple nodes, Neumann, all of these things. What are those abstractions? And then, of course, also how do we express the computation so that it can make use of these abstractions and be fitted to this very heterogeneous array of different frameworks. So I think there is a lot of good work going on, both in industry and academia in this, but there is not yet a winning answer, let's say. But from the technology side, I think we are in a good position.
Thank you,
And
Björn.
if I may, sorry, Daniel. So if I may, again, the questions are very well framed, and very deep and broad. We talked about abstraction and compilers, but the runtime stack is part of the question, and so all aspects related to scheduling, placement, they're getting, so they're the interesting ones, right? When so you have the abstraction, but so it's not just going all the way down, it's deciding where to split and where to place, how to schedule resource utilization, security, all those aspects. I think that there's a reach. I think there's a lot of research to be done there, and there's a lot that needs to be done. I mean, many things have been done, but they need to be repurposed and reframed and to address the particular challenges that arise when we start having abstractions. So abstractions for me is the first, but given the abstractions and the ability to compile, then the runtime issues are going to be very, very important.
Thank you, Björn, and thank you also, Philippe, for the added value here. We can move on to the next question. I would also like for Björn to start this one. So in your opinion, Björn, so what are the biggest challenges in turning cloud edge AI research into deployable industrial platforms in Europe? I think we have tackled this a bit now throughout the discussion, but I would like to see now from your opinion, so what is the biggest challenge?
Yeah, so it comes back to the question that I think has been somewhere in Philippe's answer for every question so far, which is who is going to drive this, right? Because I think in the end, we do have a lot of good research, just everyone knows that, but it's worth making explicit. But of course, to be able to scale up, I mean, the costs are quite big, right? We need someone who has a really strong use case and also, is willing to put it all the way. And here, coming back to another point that was raised earlier, it depends a lot on, where we want to go. And I really, really like this, making explicit this transfer from, mobile devices and so on, demonstrating the technology and moving upwards and upwards. I think this is, for example, I mean, we haven't talked much about ISAs. We have talked more about general, compute architectures. But this is sort of what we see happening with RISC-V, for example. We see, okay, this comes out of academia, this gets adopted. Where does it get adopted first? Well, in the simpler processors, in the embedded systems, and then it solves very specific problems. These problems scale because we are running into the same problems at every scale. And then we scale these up until they become the workload. So at some point in each part of this process, I think there has to be the real, the driver that makes this feasible. If we are going to take all of the hardware research, well, we need to produce the chips, and who is going to use and buy those chips to pay for the manufacturing and so on. And for the software, of course, we can make a lot of interesting abstractions in compilers, but if there are no chips out there that need them, they stay on the working bench in the universities. So yeah, I don't know if that answer added more more context, but it's more of a summary perhaps of what we have been circling around.
Perfect. Thank you, Björn. So, Philip, is it uncertain drivers and or something else that are the biggest challenges in deployable industrial platforms?
So I'm going to do something that so for 2 years ago or 5 years ago, so more 5 years ago, I would never have said, but I believe so mindset in Europe is the key issue because in my mind the only way this becomes a reality is if it's led by the defense industry. And so a lot of things are happening in a non-bureaucratic way, and so there's a lot of innovation going on, and which is very much related to that space. The danger is that we have a disconnect between, so in the US, it's never been. I mean, DARPA has had a huge role in the development of the IT infrastructure. And so I've had the opportunity to be working on DARPA programs, and so there were demos on military grounds and generals at project meetings. So I believe we need a much better traction and integration of defense needs with research outputs. So for a long time, an EU project dual use was we had to be very far away from any form of dual use. So I think in terms of mindset, so again, 5 years ago I would have said never. Environmental monitoring was the only thing that mattered. Today I believe so. This is going to happen. And so I believe that there's a need for very strong regulation and very clear aspects, which again we should champion in Europe. But I believe that there should be an efficient traction between the defense industry and academic research, and I believe So we don't have DARPA, and I believe the European Union, and it's not clear to me how it can happen right now, but I believe that's their role.
Perfect. So who are the drivers? Can we change our mindset? And I would add on this, are we ready to take some risks as well? So this would end the questions that we have prepared for you. Now I would like to leave the floor open to our participants, but also to our speakers if they have some open questions as well. So feel free to write a question down in the chat, or if you feel comfortable talking, feel free to raise your hand and ask the question directly. So I will leave this space open for a couple of seconds for the bravest.
Everything is crystal clear.
Thank you, Björn, as well. But I would like actually to come back to what I said. So what are the risks for Europe when it comes to cloud edge AI systems? So what would be we have to risk in order to make them, let's say, more deployed in industry?
I think, if I may, so one of the points that it's related to your question, but it's related to a previous question as well, is the fact that we're talking about memory centric, we're talking about memory. Memory comes from South Korea. So it's not something, I mean, there's a lot of emphasis in Europe on RISC-V processors, but, the memory is not, nobody, I mean, there might be a few small exceptions, but nobody is developing memory technology in Europe. So if memory-centric processing is going to be is going to be a key, then we have to work very, very closely with South Korea and Japan as well, because they're in the same boat as we are in terms of not having scale is not everything. So I believe so you mentioned, it was mentioned earlier in your slides, and that's part of what the OpenNexus is, the NexusForum is working on. But I believe it's, especially in that space, it's going to be very, very important. And that's one of the, in terms of risk, I don't know if it's a risk, but we have to find ways to work very efficiently with colleagues and industry in South Korea and Japan.
Absolutely. Thank you very much, Philippe, on this. I think while also having digital partnerships with South Korea and Japan is the first step into realizing this, and also the results of projects such as NexusForum. Björn, any last thoughts from your side?
No, not particularly that have not already been voiced. But I think these are super interesting questions, and I just want to link it a little back to the working group. Because I think, as mentioned, there are many working groups, and they all come together with their particular, interests or topics that they are looking out for. So what is special for our working group is really that we are looking this deep down in the stack, right? And what we are seeing here with respect. So we can always write applications. In the end, it doesn't really matter what it's running on. We can run it on wood, worst case, you know. But here is, I think, this entire area that this working group has worked with is the risk, right? There is very little in Europe. There are a few, companies that are based here and that are important for the infrastructure and so on. But really, everything is happening in Asia and the US in this area in general. So I think that's sort of it's hard to single out a single thing, but of course, memory is definitely among them.
Perfect. I think this is a great insight to have as a final one. But to discuss more insights, we also invite everyone to join the NexusForum final event. It is going to be an online event on June 16th at 10 a.m. Central European Summertime, where we'll be discussing all the results that we have had produced within the project. So we'll be discussing the digital policy recommendations. We'll be discussing as well, of course, the roadmap. We'll be discussing the ways we can turn this into reality and how to actually implement it. We will also have the representatives of the European Commission and in the international landscape from Japan delivering their keynotes and their insights about the importance of this topic. So I encourage everyone as well to sign up for this final event. Of course, it is free of charge, and you can find more information on EU Cloud Edge IoT website, where you can also find the registration link. Once again, I would like to thank everyone that has joined, especially Björn and Philip, for great insights that you have shared. My name is Daniel Pavlica, and it was also my pleasure to host today's webinar. We'll be having several iterations of other webinars in the upcoming weeks, so we also invite everyone to stay tuned and to follow us on our channels. So I wish everyone a great day, and thank you very much for joining us.
Thank you so much.
Thank you very much.